Welcome back to my Math YouTube channel. For this video, I will discuss problem solving involving compound interests when time is unknown. Please remember this, why knowing the time in compound interest is important. Investors or depositors are interested to know how much time is needed to accumulate a desired amount in investing a certain principal. No further ado, let us now discuss the conversion of formula in computing time in compound interest. From the basic formula of the future value of compound interest, f equals p quantity 1 plus j raised to the n, where j is equal to I raised to the parenthesis m over m and n is equal to mt. We all know that time or t is on n. So our objective is to convert the formula for n. First, eliminate the principal by dividing p both sides. So we have f over p equals quantity 1 plus j raised to the n. Since we have the exponent n, to simplify it, we can use the laws of logarithm. By then, we have the logarithm of f over p equals the logarithm of quantity 1 plus j raised to the n. One laws of logarithms states that the logarithm of x to the n with base b equals n log of x with base b. Applying to the formula, the logarithm of quantity 1 plus j raised to the n will become n log of quantity 1 plus j. The exponent n became now the coefficient, which is easier to solve. To make n independent, we will divide both sides by log of quantity 1 plus j. To continue, we can now cancel on the right side the logarithm of 1 plus j. Therefore, the formula now for n is equal to the log of f over p over the logarithm of 1 plus j. Problem number 1. How many years will it take that 120,000 pesos will become 150,000 deposited in a bank that offers 8.5% compounded quarterly? The givens on the problem are: the principal is 120,000, the future value is 150,000, the nominal rate is 8.5% or 0.085. The conversion is quarterly, it means 4, and the time is unknown. Substituting the given values on the derived formula, we have f equals 150,000 over p, which is 120,000, over the logarithm of 1 plus j, which is 0.85 divided by 4 because j is equal to I raised to the quantity m over m. To solve, simplify first the numerator. 150,000 divided by 120,000 equals 1.25. Divide also the fraction part of the denominator. 0.085 divided by 4 equals 0.02125. Next, add the denominator. 1 plus 0.02125 equals 1.02125. Using scientific calculator, get the logarithm of both the numerator and denominator. The logarithm of 1.25 equals 0.09691. The logarithm of 1.02125 equals 0.00913. Divide the results. 0.09691 divided by 0.0913 equals 10.61. And we have now the exact value of n, which is 10.61. Since n is equal to mt, we will continue to solve for the time. By substitution, we have 10.61 equals 40. To remove 4 from t, divide 4 both sides. 4 is cancelled, t is remain. 10.61 divided by 4 equals 2.65. And finally, for this particular problem, we are now through solving for the time. So we can now say that to accumulate the desired amount, it will take 2.65 years.
Another one.
For our next problem, how long will it take for 50,000 to earn 18,000 at 12% compounded semi-annually. In the problem, the principal is 50,000, the future value is principal plus the compound interest equals 50,000 plus 18,000 equals 68,000. The nominal rate is 12% or 0.12 semi-annual conversion, so M is equal to 2 and time is unknown. Substituting on the formula, F equals 68,000, P equals 50,000, J equals 0.12 divided by 2. Again, simplify the numerator. 68,000 divided by 50,000 equals 1.36. Simplify also the fraction part of the denominator. 0.12 divided by 2 equals 0.06. Add the denominator. 1.0.06 equals 1.06. Using scientific calculator, get the logarithms of both the numerator and denominators. The logarithm of 1.36 equals 0.1335. The logarithm of 1.06 equals 0.0253. Simplify further the result. 0.1335 divided by 0.0253 equals 5.28. And that is now the value of N. Again, since N is equal to empty, by substitution, 5.28 equals 2t. Dividing both sides by 2, 2 is cancelled, t is remain. 5.28 divided by 2 equals 2.64. And that is now the value of t. Therefore, for this particular problem, we can now say that in order for 50,000 to earn 18,000 at 12% compounded semi-annually, it will take 2.64 years.
Ma'am, galing mo pala dyan ah. Hindi ko alam ah.
Another one.
Next problem, problem number 3. How long will it take for 37,000 accumulate 69,000 in an account at 5% compounded monthly? On the problem, the principal is 37,000, the future value is 69,000, the nominal rate is 5% or 0.05 compounded monthly, so M is equal to 12 and T is unknown. Substituting the given values on the formula, F over P equals 69,000 over 37,000. J is equal to 0.05 divided by 12. Simplify the numerator. 69,000 divided by 37,000 equals 1.8649. Divide also 0.05 and 12. The quotient is 0.00417. Add the denominator. 1.0.00417 equals 1.00417. Again, using scientific calculator, get the logarithm of both the numerator and denominator. The logarithm of 1.8649 equals 0.2707. The logarithm of 1.00417 equals 0.0018. Divide the results. 0.2707 divided by 0.0018 equals 150.39. And that is now the value of N. Again, since N is equal to empty, by substitution, we have 150.39 equals 12t. To remove 12, divide both sides by 12. 12 is cancelled, t is remained. 150.39 divided by 12 equals 12.53. And finally, we got the value of t. Therefore, in this particular problem, in order for 37,000 to become 69,000 at 5% compounded monthly, it takes 12.53 years. Again, if you learn from the video, please do like and share. Browse my channel for more math tutorial videos. Thanks for watching.